Hello everyone, welcome back to our channel. Today, we dive into a very important topic, the bottleneck of Raman imaging speed. Raman spectroscopy is inherently a weak phenomenon requiring some time, typically from sub-seconds to several seconds, to gather enough signal for analysis. When it comes to 2D or even 3D mapping, the required time increases exponentially as more data points are collected. The scattering cross-section of a molecule is decided by its structure, which is a fixed property we cannot alter. However, one factor we can manipulate is the excitation wavelength. Shorter wavelengths can enhance the scattering process, as this effect scales with the force power of the inverted wavelength in the equation. Unfortunately, there are trade-offs. Shorter wavelength lasers are often less powerful and have reduced efficiency in optical elements and detectors. For most examples, the optimal balance between scattering efficiency and practical usability lies in the blue-green wavelength range. While UV Raman spectroscopy has unique capabilities, it is not generally a practical solution for faster imaging. Having ruled out the factor we cannot change, the path forward becomes clearer. We improve the laser power. In theory, doubling the laser power would double the number of Raman scattered photons, allowing us to achieve same signal in half of the time. It sounds straightforward, but in practice, it's far more complicated. Consider this, a light source of 1 watt isn't even sufficient to keep a cup of coffee warm. But when that 1 watt of energy is focused into a small laser point, it can burn many materials. For Raman imaging, achieving high spatial resolution requires focusing laser onto a tiny spot to capture structural details. This creates a fundamental conflict. High laser power are more likely to damage the sample, limiting our ability to increase laser power and, consequently, the imaging speed. Despite these challenges, there are possibilities to overcome this limitation. Let's explore some of the approaches in our next video. Thank you for watching and see you next time.